Factoring trinomials, part 2. You may have noticed that all of the trinomials that we factored in the first video had a leading coefficient that was 1. All the polynomials we are going to factor in this section have a leading coefficient that is not 1. You can do these by trial and error, but I'm going to suggest a strategy that is different than that. We're going to turn them into 4-term polynomials and factor them by grouping. Here's how that works. The first step is to multiply the leading coefficient times the constant. So 4 times 3 is 12. Then what we want to do is something similar to what we did in the last lesson. We want to look at all the factor pairs of 12 and find the factor pair that actually creates 8 as its sum. So 1 and 12, 2 and 6, 3 and 4. 2 and 6 actually make 8. So we're going to call this 2x and 6x. And we're going to rewrite our trinomial as a 4-term polynomial. The 4x squared is going to stay, and the 3 is going to stay. But instead of writing 8x, we're going to write it as plus 2x plus 6x. Now we've got 4 terms, and I am going to factor them by grouping. So 2x in common for the first 2, leaving me with 2x plus 1, plus 3 in common for the next 2, leaving me 2x plus 1. 2x plus 1 is now common to both terms, so 2x plus 1 times 2x plus 3. Let's try that again. 4 times negative 10 is negative 40. Factor pairs 1 and 40, 2 and 20, 3, 4 and 10, 5 and 8. It's a negative 40, so one of these two has to be negative. Since I want negative 3x, I'm going to make the bigger one negative in each case. 5 plus negative 8 makes negative 3, so I'm going to call this 5x and negative 8x. 4x squared will stay, minus 10 will stay, but negative 3x is now going to be plus 5x minus 8x. And I will factor by grouping. The first two have x in common, leaving 4x plus 5. The next two have 2 in common, but I'm going to factor out negative 2 so that I end up with 4x plus 5. Now they both have 4x plus 5 in common, leaving me with x minus 2. 6 times 3 is 18. 1 and 18, 2 and 9, 3 and 6. I want it to be a positive 18, but I'm trying to get them to add up to negative 11, so I will make them both negative. The pair that actually works for me is negative 2 and negative 9. So I'm going to write this as 6x squared minus 2x minus 9x plus 3. The first two terms have 2x in common, leaving 3x minus 1. The next two have 3 in common, but in order to get this to result in 3x minus 1, I'm going to have to factor out a negative 3. So that will make 3x minus 1, because negative 3 times negative 1 would be my positive 3. They have 3x minus 1 in common, leaving 2x minus 3. 6 times negative 10, negative 60. That's 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. One of them has to be negative, and since I want negative 17x in the middle, I'm going to make the bigger one negative. The pair I want, 3 with negative 20, so I'm going to put an x on each of them. 6x squared plus 3x minus 20x minus 10. 3x in common, 2x plus 1. 10 in common, but I'm going to call it negative 10, so I get 2x plus 1. 2x plus 1, 3x minus 10. 5 times 8 is 40. Do you see it? Like I see it. I'm trying to make 14. I think the pair is 4 times 10. Then I don't have to list them all. And if you see it, you don't have to list them all either. 5x squared plus, now you might say, well, what if I wrote the bigger one first? 10x plus 4x plus 8? It really doesn't matter which order you put these in. They have 2x, oh, pardon me, that's not right. They have 5x in common, leaving 2x, no, oh dear, leaving x plus 2. They have positive 4 in common, leaving x plus 2. Now we have x plus 2 in common, leaving 5x plus 4. Negative 210. Wow, negative 210. I'm afraid of that one. So I'm going to let my calculator make factor pairs. I'm going to go to y equals, oh, I'm in the wrong mode. Sorry about that. You will not be in the wrong mode. Okay. I'm going to go to y equals, and I'm going to put in negative 210 divided by, and instead of putting in a number, I'm just going to put in my variable x. And then I'm not looking at the graph. I'm going to look at the table. So that's the second function of graph. Okay, my table is already sort of into itself, but look, 1 and 210, 2 and negative 105, 3 and negative 70, 4 and a decimal, 5 and negative 42, 6 and negative 35, 7 and negative 30. Now, what was I looking for? I was looking for negative 1. So let me come down to my table and keep going, because 7 and negative 30 isn't negative 1. 8, no. 9, no. 10, no. 11, 12, no. 13, no. Ooh, 14 and negative 15. Okay, so I'm going to use 14 and negative 15, because that would make negative 1. So you might say, I sort of like the 14 with the 21 and the 15 with the 10. I do too. 10x squared minus 15x plus 14x minus 21. Okay, definitely. 5x, so 2x minus 3 plus 7, 2x minus 3. So I have 2x minus 3 and 5x plus 7. Okay,